Blockchain, cryptocurrency, NFT, decentralization, DeFi, DAO. Whether you ask investors or venture capitalists or technology enthusiasts on social media, Web3 is supposed to be the next big thing for technology. And in the future, everything you do, from posting content on the web to making a financial transaction, will be turned into a token stored on the blockchain. Now, depending on who you are and where you are and what you know, this may sound awesome, or terrifying, or just plain confusing, or all of the above at the same time. So let's make sense of this together. I've spent a lot of time researching decentralization, blockchain technologies, and this idea promoted as Web3, and I've made this course as a dictionary of sorts to help make sense of the jargon and technologies underpinning all of this. This course is split into two chapters. The first chapter is a high-level explanation of the idea referred to as Web3 and the next version of the web. The second chapter is a deep dive into how blockchain technology works and what all the terminology associated with blockchain means. Having a firm grasp of the principles and practices around blockchain and Web3 ideology gives you the power to have meaningful conversations about our shared future, and I'm here to help you get it right. So let's get cracking. To make sense of what Web3 is, it's necessary to understand the number 3, as in why Web3 specifically. This has to do with how we talk about the evolution of the web. The original World Wide Web, created in the early 1990s, was effectively Web 1.0, the first version. On Web 1.0, most content was static. Most people were consumers of existing content, and there was very little communication between people and the websites they used. We consider the Web 1.0 era to be roughly between 1991 and 2004. Web 2.0, the social web, came about thanks to the emergence of tools and platforms making it easy for people to create and publish their own content on the web and to have ongoing interactions with other people through the web. The web went from being an information resource to being a communication platform. This revolution started with message boards and blogs and quickly evolved to the social media platforms we have today. We're still very much in the Web 2.0 era. Based on this, the next evolution of the web would logically be Web 3.0. The question is what that evolution would be. World Wide Web inventor Tim Berners-Lee suggested the next evolution of the web be the semantic web, where all data is machine-readable and can be parsed by machine learning algorithms and AI through unified APIs. Others have suggested it would be the spatial web, where we move from interacting with the web on rectangular screens to having the web embedded in the environment around us. Smart speakers and other IoT devices are the beginning of this spatial web. Yet others have suggested it would be the metaverse, a vaguely defined alternate reality built in cyberspace where we are represented by avatars and interact with one another through VR or AR goggles. Now, underlying all of these ideas lies a more technical premise of the decentralized web, where data is distributed among users and available everywhere. This stands in sharp contrast to where we are today, as most services and data are centralized under large platforms and companies. All of these ideas combine to paint a picture of a possible future Web 3.0. But then there's this other thing called Web 3, no spaces, no .o. This idea, Web3, was introduced by Ethereum co-founder Gavin Wood in 2014 and describes a decentralized and tokenized web ecosystem based on blockchain technology. Everything is decentralized and we manage all data on blockchains. This moniker, Web3, no spaces, no .o, quickly gained popularity and became an umbrella term encompassing all blockchain-based technologies, including decentralization, cryptocurrencies, decentralized finance, non-fungible tokens or NFTs, decentralized autonomous organizations or DAOs, and a vision of the future where power and data is taken from centralized corporations and banks and handed to the individual user. So, as we step into this conversation, keep these two things in mind. Number one, when people talk about Web3, they are probably talking about decentralization, cryptocurrencies, and the blockchain, but There's also a small chance they're talking about all the other Web 3.0 stuff, so semantic, spatial, decentralized web, and the metaverse, so it's worth asking. And number two, Web3 is an umbrella term describing one possible future for the web promoted by people heavily invested in cryptocurrencies and blockchain technologies. We're not there yet, and this is not the only possible future for the web. Imagine you put on a pair of VR goggles, a headset, and some connected gloves. Suddenly, you're transported to a digital world where you can interact with people and things. In this interactive world, you have a whole separate existence. You have a full-body avatar representing you that you can style and dress any way you want. That avatar can live in a space you design. It can have a job where it either does work automatically or you actively do the work by controlling it. It can earn an income, buy and sell items, function in every way like you would in the real world, except it's a virtual world, a virtual reality, if you will. This is the metaverse, and yes, you've seen this movie before. Metaverse is a new name for an old thing we've been both promised and warned about since the early 1980s, a digital world that is somehow better and more enticing than our own. With the advent of better technologies, especially in the VR department, social media, and during the COVID-19 pandemic, our habituation to interacting with other people through video chat, this idea of a virtual alternative world has gained a lot of steam. So what does the metaverse have to do with decentralized Web3? That depends on who you ask. One of the major challenges of running a truly virtual world is setting up a separate economy for it. The blockchain-based Web3 provides a solution to this challenge through its foundation in cryptocurrencies. Another problem, funding the development of such virtual worlds, can also be solved through Web3 by setting up DAOs, decentralized autonomous organizations, that sell NFTs, non-fungible tokens representing assets in the metaverse, to fund development. I say this is possible because it's actually happening right now. There's a tug-of-war playing out in the tech industry between old behemoths like Meta, formerly Facebook, trying to build their social media giant into a walled garden metaverse, and Web3 enthusiasts wanting to build their own laissez-faire economy in a metaverse on decentralized Web3 with cryptocurrencies funding and running the whole thing. Now, regardless of who wins, the metaverse will most likely manifest as a virtual space where we can meet and interact with others as our chosen avatars over the internet, buy clothes and things for our virtual avatars in the form of NFTs, partake in voting on new features in the virtual space through DAO tokens, and earn a virtual living through virtual work paid in virtual cryptocurrencies. Web3, again, no spaces, no .o, is not the name for the next version of the web. It's a very specific vision for one possible future for the web with a very specific origin. Understanding where this idea comes from helps us understand the promises it's making and trying to fulfill. The root of Web3 ideology is all about power, specifically taking power away from large centralized entities like banks, social media platforms, and web services, and handing that power over to the individual user. This will, according to Web3 supporters, be achieved by placing all data on distributed decentralized blockchains and decentralized storage, and turning all financial transactions into transactions on that blockchain. Because the blockchain is decentralized and decisions are made by consensus, the argument goes there is no longer a need for centralized authority with power. In fact, centralized power can't exist in this decentralized future. Instead, everyone has power and everyone has control over the assets that live on the chain. The idea of Web3 is very much a pushback against surveillance capitalism. It's a real-world manifestation of the feeling of powerlessness in people who have grown up in a digital world dominated by so-called free services who collect every bit of data and use it to manipulate the users through ads and recommendation algorithms. It's also a manifestation of what I call a techno-utopian libertarian view of the world, where every problem can be solved if we just throw enough technology at it, and the biggest problem of all is moderation and regulation. Bitcoin, the first true decentralized cryptocurrency, grew out of the 2008 financial crisis. Its creators saw how centralized banks were able to speculate with other people's money, crash the entire banking system, and then run away with the profits while regular people suffered the consequences. What if we build a global currency bypassing the entire banking system, they thought? And what if we make it impossible to track how much money anyone has or who they trade money with? That way, governments have no control over money and everyone is free to do whatever they want. The decentralized blockchain is a technology built on laissez-faire capitalism and meritocratic rule, and this way of thinking permeates through the entire Web3 ideology. It's important to understand two key characteristics of this ideology. First, everything becomes a transaction stored forever on an immutable ledger, the blockchain. And second, everything on the blockchain has tradable value because it is on the blockchain. On the proposed Web3, every transaction on the web, from uploading a file to posting a social media status update to making a payment or an appointment or checking your health records, ends up as a transaction or token on the chain, and each transaction and token has potential value. Creating these tokens takes energy, which is paid in cryptocurrencies. Earning cryptocurrencies is done by verifying and adding new blocks to the chain. The entire Web3 ecosystem is centered around turning everything into a securitized token, a tradable asset, and assigning a value to that asset. The promise of Web3 is to re-engineer the entire web ecosystem to be built on blockchain technology and make the distributed blockchain the single source of truth for everything we do on the web, from social media posts to finance to property deeds to medical records. Which is why, as I write this, the same venture capitalists and platforms and banks Web3 promises to take power away from are pouring billions of dollars into building Web3. In this proposed future, the blockchain will be the most valuable data source in the world, and access to what is on the blockchain and control over what goes in the next block will be where the true power lies. The central point on which all visions of a third stage of the web, aka Web3, pivots is decentralization. So what is decentralization of the web? Here's a simplified explanation. To make a service like a simple website enabling real-time chat available to people through the web, that service must live somewhere. On today's web, that somewhere is typically a web host or a cloud host. This host becomes the single source of truth for the website and the chat app, and everyone interacts with it through that host. This is centralization of services. The service is located in a central location. Centralization is easy and effective because we're dealing with a single source of truth. It's also problematic because it makes the service reliant on a single point of failure and because centralized control over data is valuable. On the centralized web, if the centralized host goes down, the service goes down as well. On the centralized web, large centralized platforms like social media own and control the content and interactions happening on those services. And that means they can apply content moderation, refuse service, even block access based on factors like where you're located or your previous history of interaction. Decentralization aims to solve these issues and more by distributing data between all users of the platform. There are many ways of doing this. Here are two examples: federated decentralization and absolute decentralization. In a federated system, multiple different autonomous and independent data sources, typically databases, are mapped together to operate as one cohesive unit. So for example, instead of your posts on a social media site sitting on a centralized host, they may sit on any hosted service you choose and then be federated or combined with other posts from other services to appear as one cohesive whole. The data doesn't live in one central location, and each individual user has control over their own data and where it's hosted. This model is fast and doesn't require a lot of power, but it's also brittle in that data lost on one node may be lost to everyone. In an absolute decentralized system, full copies of the data are distributed to all participants. So when a new participant wants access to the data, they can pull it from whichever source is closest to them. This model can be fast and requires a lot of computing power because every update has to be distributed to every node. In return, we get persistent data. Losing one node doesn't matter because copies of the whole dataset exists everywhere. In both these models, federated and absolute decentralized, no centralized authority owns the data and controls access. Instead, everyone owns the data and each user can control who accesses their data. At least that's the goal. When you hear people talk about decentralization and taking power back from big corporations and platforms and banks, this is what they're talking about. Remove the middleman, the central source of truth. While classic Web 3.0 projects tended towards the federated decentralization model, blockchain-based Web 3 decentralization focuses almost exclusively on the absolute decentralization model because that's how the blockchain itself works. The conversation around Web3 and blockchain-based technologies is rife with acronyms and shorthand, many of which have made their way into the mainstream through financial and tech news. All of these center on the idea of decentralization, and all of them are in some way connected to the blockchain, which is why we consider them part of Web3. Let's break them down. The most prominent of these is DeFi, or decentralized finance. In a simplified way, when you hear DeFi, think financial transactions without a bank on the blockchain. DeFi services use smart contracts, automatic self-triggered logic functions, on the blockchain to offer peer-to-peer financial instruments. The idea is, instead of using banks, brokerages, and exchanges to transfer money, make investments, or do other financial transactions, everything goes on the blockchain, and smart contracts on the blockchain do the work previously handled by expensive intermediaries. And that's the whole point of DeFi. Get rid of the expensive intermediaries, i.e. the banks. Another term you'll hear is GameFi. This is a catch-all name for decentralized games that integrate with blockchain technologies to turn game rewards into money you can trade, invest, and borrow against. For example, in a GameFi game, you can get paid in cryptocurrencies for winning battles, growing vegetables, or renting out your land so others can mine it for minerals. Imagine being able to trade the rewards in a game you're playing on your phone or a game console for digital currency. You can then either buy other things within the game, or invest outside the game, or even buy things in the real world with your game winnings. That's GameFi in a nutshell. There are several GameFi services with thriving ecosystems already running on this structure, and there are people who have made playing these games into a full-time paid job. A third acronym you'll likely hear more about is DeSci, Decentralized Science. I'll let the DeSci Foundation explain this one. Quote, Web3 technologies such as decentralized storage, smart contracts, and decentralized organizations, DAOs, enable new possibilities for how science is incentivized, evaluated, financed, and shared with the world. These emerging new technologies have the potential to contribute to a scientific ecosystem that is more verifiable, more open, fairer, and of higher quality, end quote. So in basic terms, put science on the blockchain. This is still more of an idea than it is an actual thing happening in the world, but it's coming. As interest and investment in things associating themselves with Web3 grows, there will be more of these acronyms, and they will generally follow these same naming conventions, either D something for decentralized or something phi for blockchain-based something. Much of our interaction with the modern web is done through web-based applications. LinkedIn Learning is a great example of this. You log into a website or an app and gain access to a wide variety of features within that application. Now, these apps are typically centralized, meaning the data stream in and out of the application goes through the app provider. On Web3, where decentralization is the name of the game, this type of application becomes a decentralized app, more commonly referred to as a dApp. A dApp comprises smart contracts on the decentralized blockchain. Think of these as the API layer, and front-end user interface and back-end data store hosted on decentralized storage services. When you interact with a dApp, you're accessing the front-end interface, and that interface then communicates with the smart contracts on the blockchain. The smart contracts operate as the de facto API for the blockchain and for decentralized storage, and control how you work with the data on blockchain and in the storage. So combined, the dApp makes the rather complex operation of doing things on the blockchain and in decentralized storage easier, which is why the idea is so popular. So if we strip all the jargon away, a dApp is a user-friendly interface for the blockchain and for decentralized storage. Nothing more, nothing less. For a dApp to be truly considered a dApp, certain conditions must be met. First, it must be decentralized. This is achieved by placing the smart contracts on the blockchain and the front end and data store on decentralized storage. Second, it must be deterministic, meaning the dApp performs the same function no matter what environment it's executed in. That way, it doesn't matter if the front end you use is web-based or an app on your phone or something else. The same input always produces the same output or result. Third, it must be Turing complete, meaning it can perform any action it's set up to perform, provided it's given enough resources. And finally, it's isolated, meaning the operation or malfunction of a dApp is not impacted by and does not affect any other dApp or entity in the same system. This is especially important since the dApp lives on the blockchain. The benefits of a dApp are obvious. Decentralization offers persistency, data security, and integrity, and, if it's set up to do so, privacy and resistance to censorship. On the other hand, there are some obvious drawbacks. Smart contracts on the blockchain are difficult and expensive to update. A new contract must be added to nullify the previous one, meaning the traditional incremental updates we see in Web 2.0 apps will be much more difficult to roll out. Because the backend of a dApp is hosted on the blockchain, all standard blockchain challenges, including scaling, network congestion, network cost, etc., all come into play.
Also, building seamless and easy-to-use user interfaces and experiences on top of the blockchain has proven to be very difficult because of everything from the need to exchange public and private keys to significant network lag. And the most obvious solution to these issues all involves some form of partial or complete centralization, which breaks the first requirement for a truly decentralized app. The core of Web3 is built on the blockchain, but the blockchain can't store most of the information on the web. In fact, storing anything beyond basic transaction information on the blockchain is both slow and prohibitively expensive. To address this problem, Web3 needs to decentralize storage and connect that storage to the blockchain. Now, we already have a system that works here, peer-to-peer file sharing. If you were around in the 1990s and early 2000s, you may remember peer-to-peer technology being used to share music and video files, and this technology eventually evolved into BitTorrent, which is decentralized storage in all but name. I share a file on a network, someone else downloads that file and also shares it, then other people download and share the file, and soon the file persists in the decentralized network even if I turn my computer off. Decentralized web storage is a further evolution of this idea, and IPFS, the Interplanetary File System, is one of the most built out and operational versions of this idea. Here's how IPFS works. When a file is stored in IPFS, it's packaged in IPFS objects, each containing 256 kilobytes of data. If the stored file is bigger than 256K, which most files are, several objects are created, including an index object explaining how to put all these objects back together to recreate the file. Each object is given an encrypted hash describing the file, which serves both as the address for the object and as proof the object has not been tampered or altered with. These objects are placed on the network and duplicated by any IPFS node, so any computer or server running IPFS that accepts new objects. This is the decentralized part. The objects are distributed on the decentralized network. To retrieve a file from IPFS, you send a request with the hash address to the index object to the network, and the matching IPFS objects are returned to you from whichever nodes are closest to you. But this is a bit of a problem. When a file is changed, the file hash changes with it. So that means if a file is updated, the address to that file changes as well. This doesn't work all that well for things that can update, like applications or websites. To solve this problem, you can set up a mutable pointer, a literal link to something that can be changed over time, so whenever a new version of a file is added to the network and a new set of file objects are created with new hashes, the pointer redirects to point at the new version while leaving the old versions on the network as well. This means even though you update a file, the original file will remain on the network and be retrievable, which gives us historical permanence. So how does the blockchain fit into all this? By adding domain names on the blockchain through services like ENS, the Ethereum Name System. Blockchain domains are NFTs that point to pointers or addresses. So if you set up a file on IPFS, you can map the address of that file to your ENS domain NFT. This also means anytime you need to change what your domain points at, you need to update it on the blockchain. This method of file storage and retrieval is fundamentally different from how the web currently operates. On the traditional web, the web we're working on right now, you request files from a specific address, a domain name mapped on the global DNS, the domain name system, to an IP address. That's what HTTP, the Hypertext Transfer Protocol, does. Points at a physical location on the web from which we pull files. With ENS and IPFS, you request files by querying the blockchain for the address the ENS NFT points to. That request is sent to IPFS, and the network returns the matching IPFS objects from wherever they are stored, and finally your browser reassembles them into the files you requested. This process is a complete rewrite of how the web operates based on a whole new set of protocols and protocol interfaces for both blockchain-based domain name services and for decentralized file retrieval. As I record this, only a couple of browsers, namely Brave and Opera, support ENS and IPFS out of the box, though you can also get extensions for many other browsers to add support, and there are now Web3 browsers coming online as well. Decentralized storage is not a new problem, and long before the ideas of the decentralized blockchain or Web3 were conceived, people were hard at work trying to decentralize the web. In addition to the obvious issues like user experience, user friendliness, and speed, there are some significant hurdles decentralized storage solutions need to overcome before they can become the standard. Here are some of them. Number one, how do we get people to store other people's files? In the traditional peer-to-peer file sharing model, where people were sharing files other people wanted, like music and movies, getting other people to store your files was not difficult because the incentive was to have access to the files. In a truly decentralized storage environment, though, that incentive doesn't exist, or at least it's negligible. Who would want to store CSS files for some random website, or a document, or an FAQ page, or some images for a random product? To get people to share their space on a decentralized storage network, a new incentive must be introduced. The current best answer, introduced by IPFS, is a new storage-based cryptocurrency called Filecoin. Make space available for IPFS to store files, and you earn Filecoin. Need other people to store your files? Pay for that storage with Filecoin. Make Filecoin a blockchain-based cryptocurrency, and storage becomes a tradable commodity people will use as investments. Turn free storage on your computer or server into a moneymaker. Which brings us to issue number 2, equity. For decentralized storage and cryptocurrencies like Filecoin to succeed, large numbers of users must buy into the system by sharing their available storage space and internet connections. But this assumes most users have available data space to share and access to cheap, reliable broadband internet. This is often not the case in large parts of the world and puts people without storage space and internet connections at a significant disadvantage. Some users try to get around this problem by placing their IPFS nodes on centralized servers and cloud hosts, but this counteracts the intentions of decentralization, which is to take power away from those same services. So for decentralized storage and Web3 to succeed, we as a society first need to address global inequity. Even if we solve this equity problem, there is an even more sticky problem to be solved. Number 3, data permanence. The old, as in current web, is built on the premise of data mutability. Nothing on the web is permanent. You can create a domain name and change where it points to. You can set up a server and change its IP address. You can upload a file and then modify or delete it later. This flexibility is what allows us to rapidly evolve the web and the sites and applications that run on it. This mutability is great for content publishing, design and development iteration, and privacy. Things can be deleted off the web, but in a centralized storage environment, centralized powers, including service providers, law enforcement, and governments, can control what content is available and even censor or delete content. In a decentralized storage situation powered by the blockchain, data immutability, data permanence, is implied and often essential. If a blockchain domain points at a resource and that resource is modified, the system breaks. A real-world example of this is when an art NFT is sold and the image the NFT points to is deleted. For the NFT to retain its value, the storage of the artifacts that it points to must be permanent and immutable. Additionally, immutability is necessary to ensure files in a decentralized network are not tampered with. Those of us who lived through the days of peer-to-peer file sharing will remember viruses being distributed as MP3s. To avoid this problem, once a file is uploaded to a decentralized storage system like IPFS, it cannot be changed. If the file needs to be updated, a new set of IPFS objects are added to the system, and those new objects contain the addresses to the old versions. This gives us not only data permanence, but data history permanence. If you're concerned about losing data or data being censored or blocked, this is great. If you need the ability to remove data for any reason, or someone uploads data that is somehow harmful, like personal information, abuse content, criminal content, this is all very bad. Additionally, laws like Right to be Forgotten, GDPR in the EU, and the California Consumer Privacy Act, or CCPA, explicitly give anyone the legal right to demand that their data is removed. This is very difficult to achieve in a system built for data permanence, where a single node refusing to delete data means that data persists indefinitely. As a result, decentralized storage is not only a technical problem, it's an ethical, ideological, legal, and political problem, and all of these issues need to be addressed for Web3 to meet its own promises.
To understand this term Web3, it's necessary to really understand what the blockchain is and how it works. That's what we'll focus on in this chapter, starting with the blockchain itself. A blockchain is an immutable or unchangeable ledger of information. It's a chain of blocks, each containing information about transactions, telling a linear story about all transactions that have ever taken place. Once a transaction is added to a block and that block is added to the chain, it can never be modified, so the information becomes permanent and is therefore immutable. The clever trick that makes blockchain technologies popular is how they ensure this immutability. Think of a regular ledger of transactions. If I want to make a change to the history of the ledger to alter or remove a transaction that has happened in the past, all I'd have to do is find the right entry, make my changes, and just make sure the ledger still adds up. Nobody would be the wiser unless I made a mistake. This is not possible on the blockchain because each new block contains an encrypted copy of all the previous blocks. That way, if I go in and try to change a transaction in a past block, the block would no longer match the encrypted copy in the next block, and everyone can see the chain has been tampered with. This is achieved using an encryption algorithm that is easy to test, typically SHA-256. Add some data, for example a line of text, into a SHA-256 calculator and it'll generate a unique encrypted hash, a string of seemingly random letters and numbers representing that line of text. Enter the same line of text and the SHA-256 calculator will return the exact same hash every time. But change any letter of the sentence and the entire hash is changed, making it easy to see that something has been changed in the original sentence. This makes it easy to compare two copies of the same data. Put them in a SHA-256 calculator and see if you get the exact same hash in return. If the hashes match, the copies are identical. If not, something has been changed in one of them. On a blockchain, each block contains a hash of the previous block, which contains a hash of the previous block, which contains a hash of the previous block, etc., etc. So if I change a block in the past in any way, the new hash from that block will not match the hash stored in the next block. This is what makes the blockchain immutable and why the idea of a blockchain is so appealing. We get a permanent, unchangeable record of every transaction that's taken place.
A blockchain is a linear chronological chain of blocks containing transaction information about past events. So what is a block then? I find it useful to think of a block as a sealed, transparent box with stuff inside. You can inspect what's inside, but you can't change what's inside the box or block once it's sealed. So what goes into the block? What information is stored on the blockchain? Different blockchains have slightly different blocks, but they generally have the same overall structure and contents. Here's what a prototypical block on a generic distributed blockchain looks like. At the top of the block is a header containing information about the block itself. You can think of this as the block metadata. The header contains several entries, including a timestamp for when the block was created. This is used to put the block on a timeline so we know exactly when the block was created and in what sequence the blocks were created. A hash created from all the transactions within the block. This is an encryption tool used to verify no transactions have been altered within the block. If you put all the transactions from the block into a hash calculator and get a result matching the hash in the header, then the transaction data is preserved. If the hash is different, something has been altered and the block has been corrupted. There's also a hash for the entire previous block. This is used to verify the previous block has not been altered. Since each block holds a hash of the previous block, if any block in the chain has been altered, all the hashes after that one will get corrupted. This is how blockchains become immutable. And finally, in the header, there is a nonce, an arbitrary random number used once, used to create the block. This is the random number block miners guess at to create new blocks in proof-of-work blockchains. I'll explain how all of these pieces of data are used in more detail later on in the course. So for now, just remember there's header information and it's important. After the header, the block holds a transaction counter showing how many transactions are contained within the block, and that is followed by a list of every transaction in the block. In some cases, there may also be additional metadata after that, but again, that varies depending on the blockchain you're using. Now remember, since the block contains both all the transactions themselves and a hash of those transactions in the header, anyone can check whether the transactions in the block have been altered by running them through a hash calculator and checking to see if the hash in the header matches the output from the calculator. I'll talk more about this in the movie about decentralized blockchains. Bottom line, a block holds metadata about where it exists in the blockchain, security measures to ensure the block can't be tampered with, and a list of every transaction stored in that block. Web3 is an umbrella term for a decentralized and tokenized web ecosystem based on blockchain technology, specifically decentralized blockchain. So what is a decentralized blockchain? Let me explain. When you think of a ledger, you probably think of a transaction record in either a spreadsheet on a computer or in a physical book. In both cases, the ledger is the single source of truth for the transactions. It is centralized, and only someone with the correct authority can make changes to it, otherwise it would be useless. In most cases, in our everyday lives, that centralized authority is a bank. The bank holds your money and keeps track of your money as you make deposits and withdrawals and transfers. If the bank used blockchain technology for this type of ledger, it would be on a permissioned blockchain, where only someone with the correct permissions is able to add transactions to blocks and add blocks to the chain. This type of transaction is also referred to as a trusted transaction because you put your trust in the centralized authority with permission to alter the ledger. Now imagine there is no bank, no centralized authority, no intermediary managing and charging for your transactions. Instead, everyone has their own copy of the blockchain, and everyone can make transactions on that blockchain between one another without having to use an intermediary. Transactions are peer-to-peer, and whenever a transaction takes place, everyone's copy of the blockchain is updated to reflect that change. That way, all transactions are public. No centralized authority can control or make money from transactions, and there's no danger of data being lost because everyone has a copy of the transactions. This is a decentralized permissionless blockchain, also known as a trustless blockchain. If your first reaction is, I wouldn't trust this at all, you're not alone. So let me briefly explain how the blockchain adds trust to a trustless system before we dive into the details. In place of a centralized permissioned authority, decentralized blockchains use what's called a consensus mechanism to figure out what transactions go in a block and what blocks are added to the chain. These mechanisms incentivize users to add only valid transactions to new blocks, reward users who add valid blocks to the chain, and penalizes users who try to cheat the system. This, by the way, is how cryptocurrencies are mined or forged. Validate and add new blocks to the blockchain, get paid in crypto coin. Imagine this scenario. I have 2 coins, and I owe you and your friend 2 coins each. If the coins were physical coins, I could only pay one of you with my 2 coins. If we used a centralized ledger, like a bank account, again, I could only pay one of you with my 2 coins. This is how money works and why we trust banks with our money. There's a single source of truth. But in the proposed Web3, the centralized bank has been replaced with a distributed trustless ledger, and there's no single source of truth. Instead, we all have a copy of the ledger, the blockchain, and it gets updated with new blocks whenever transactions are made. This introduces an interesting problem. Let's say I tell you I'm transferring my 2 coins to you over the blockchain. You'll check your copy of the blockchain to make sure I actually have 2 coins, and then add the transaction to the next open block in the chain. Meanwhile, I go to your friend and tell them I'm transferring my 2 coins to them over the blockchain. They check their copy of the blockchain, and since the new block you added your transaction to has yet to be added to the chain, they don't know I already gave you the coin. So on their blockchain, it says I still have 2 coins. Your friend adds the transaction to the next open block in the chain as well. I just gave both you and your friend the same 2 coins. This is called the double spend problem for obvious reasons. This type of situation, where latency in the distributed system allows for conflicting things to happen at the same time, is a fundamental problem with all distributed systems. When there is no centralized authority, no single source of truth, how do we determine which transactions are legitimate and which are fraudulent? In the distributed blockchain of Web3, this is solved using consensus mechanisms, the most common of which are proof of work, or POW, and proof of stake, or POS. I'll explain these in more detail later in the course, by the way. These consensus mechanisms incentivize participants in the blockchain network to resolve conflicts by reaching consensus about what transactions are legitimate and then add only those transactions to the next block on the blockchain. This is what's referred to as mining or forging blocks. To discourage participants from adding fraudulent transactions, the system makes contributing to consensus expensive and rewards for adding valid transactions lucrative because you get paid in cryptocurrency. For our example, this means when two conflicting transactions are proposed, the network decides which is real and which is fraudulent. And by the network decides, I mean if 51% of the validators, or rather the mining computers, say that the first transaction is the legitimate one, you get the 2 coins and your friend gets nothing, or vice versa. The validators who support the winning side get rewarded in crypto coin, while the validators on the losing side wasted valuable resources and get nothing. The entire blockchain ideology hinges on this self-certifying and self-moderating mechanism. Ignore double spends, usually by approving the first spend, incentivize block miners and forgers to only add valid transactions, and penalize those who try to defraud the system. Even if you don't know anything about Web3 or the blockchain, I'm pretty sure you've heard of people mining cryptocurrencies. So what exactly is going on here? Is there a digital mine somewhere where people send their computers with virtual pickaxes to dig out coin? The mining term is confusing because it doesn't describe what's actually happening at all. And that's too bad, because the process of adding a block to a blockchain is quite interesting, in my opinion at least. Whenever a block is added to the blockchain, a new block is opened for the next set of transactions. This block will stay open for a set period of time. In Bitcoin, that period is 10 minutes, or until a certain number of transactions and other data have been added and the block size limit has been reached. When it's time to close the block, participants on the blockchain network start working on consensus for the block. This is necessary because as transactions are added in the decentralized network, there will be several different versions of history competing against each other. In most cases, it's simply a question of the sequence of events. The transaction record is linear and asynchronous, so if 2 transactions happen at the exact same time, one of them must be moved to a different time. Now, in rare cases, like our previous example, there might also be a double spend problem or other intentional or unintentional malfeasance, and decisions have to be made about what transactions end up in the block. Figuring out what transactions make up a block is done through literal consensus. Block creators, called miners or forgers depending on what consensus mechanism is used, create a block with a specific version of events and pass it to the network for validation. If the majority, so 51% of validators, accept this block as the truth, it's added to the blockchain and becomes the truth. This work of adding transactions to a block, then creating the block, and then getting validation for the block is rewarded with cryptocurrencies. For example, the present rate of mining, as in adding a block to the Bitcoin blockchain, is 6.25 Bitcoin. About 144 blocks are added to that blockchain each day, meaning 900 new Bitcoin are issued each day. In short, mining and forging means doing the work of adding transactions to blocks and adding blocks to the blockchain. The miners and forgers are then paid in crypto coin for their work as an incentive to do the work of building the blockchain. The original and still most used consensus mechanism in decentralized blockchains and on Web3 is proof of work. This is the consensus mechanism used by Bitcoin, and it is the reason why you hear about people building mining farms with hundreds or thousands of computers, why there's been a run on high-power graphics cards over the past few years, and why people talk about the enormous environmental footprint of Bitcoin. Proof of work is a validation method designed to make it expensive to add data to the blockchain. So expensive, in fact, it only makes sense to add winning blocks to the chain. This is done in the crudest possible way, by forcing miners to burn electricity by guessing a random number, and then compiling a hash, and then checking if they guessed the right number. If you guess the right number, you get paid in Bitcoin. If you guess the wrong number, you just spent a lot of money on electricity to do nothing. Here's how that works. When a new block is opened, the network generates a very complex random sequence of symbols called a target hash. Miners use their computers to throw millions of guesses at the network until someone matches that hash. When the block is set to close, remember they close every 10 minutes, whoever has guessed the hash or has the closest hash that is less than that hash wins the contest. The block is then closed and added to the blockchain, and they get paid the current rate of mining a block. At the time of this recording, that's 6.25 Bitcoin. The work in proof of work is your willingness to burn and pay for electricity to win a lottery. Now, as the number of miners go up, so does the complexity of the target hash. This is meant to reduce competition Too many miners means it's too expensive to mine, but in reality, because Bitcoin is worth more and more money, it quickly becomes an arms race. The more computers you have and the more electricity you're willing to burn, the more likely you are to win. Thus, the environmental impact being so massive. Proof of work is an enormous intentional waste of energy. So why is proof of work being used then? In part because it solves the immutability problem. To see why, let's look at what actually happens as the block is created. First, the network sets a target hash for the block. This is the number that needs to be guessed. Next, the miner creates a hash from the transaction data in the block header. This is where the hash of the previous block is stored, and guesses a nonce, a number used once. This nonce is key. If miners only use the transaction data and block header to create a hash, they would all get the same hash. The nonce, this random number, makes a unique hash, and that's the hash that needs to match the target hash. There is no mathematical method for hitting the right number here. The nonce is truly random, and the nonce that will create a matching hash is also truly random, which is why brute force is the only way to mine a new block. When the hash created by the miner is the target value or just below the target value, it's submitted to the network for verification. Other miners then check the entire block to verify everything is correct, in the process also verifying the entire blockchain has not been tampered with. Remember, each block contains a hash of the previous block, etc., and if anything had changed, these hashes will also have changed. If the block is valid and there is 51% consensus, the nonce is added to the block is closed, added to the blockchain, and a new block is opened. The miner who guessed the right nonce and mined the block is paid a reward in crypto coin. By this method, the new block contains not only the transactions, but also the hash of the previous block, which contains the hash of the previous block, etc., and the next block will contain the hash of this block. This is how immutability is ensured. The proof of work consensus model is effective but costly, both in terms of the actual cost of hardware and electricity to mine blocks, and in terms of the environmental impact. To get around these and some other issues, many newer decentralized blockchains use a proof-of-stake consensus model instead. In a proof-of-stake environment, the people creating blocks are called validators, and the creation of a block is called forging a block instead of mining a block in proof of work. Proof of stake is a lot easier to understand than proof of work because it uses staking, literally setting aside money in escrow, along with a lottery system to ensure validators don't create invalid blocks and to ensure everyone gets an equal chance to earn coin forging blocks. Here's how a block is added to a proof of stake blockchain. First, validators register with the blockchain. This is done by staking cryptocurrency in escrow on the chain. The stake can be in the thousands or even tens of thousands of dollars. When a new block is ready to be forged and added to the blockchain, random validators are picked to validate the data on the block. Validators not chosen to do the actual validation are instead assigned the role of attesting the work as part of a committee. When consensus is reached between the randomly selected validators and attested by the committee, the block is closed, added to the blockchain, and a new block is opened. Finally, validators and attesters are paid for their work, all in the form of the native cryptocurrency of the blockchain. In some cases, validators are also paid for their network transactions and compute time, sometimes referred to as gas or gas fees. So what stands in the way of validators adding incorrect data or trying to exploit the blockchain in some way? The stake. If validators act maliciously or incompetently, they lose their stake and they lose access to the network, so they can no longer take part in the staking process. Proof of stake is literally validators staking their own money as collateral to prove they are trusted actors. The central purpose of a decentralized blockchain is to maintain a ledger of transactions of the cryptocurrency the blockchain generates. The blockchain is a long chain of records of transactions of this cryptocurrency, and the way to earn coin in this cryptocurrency to transact on the blockchain is to contribute to the blockchain by mining and forging blocks and validating transactions of the cryptocurrency on the blockchain. If you don't want to do that, you can also buy coin from people who already hold coin, effectively trading real money for crypto coin. It's all a giant self-enforcing mechanism. So what exactly is a cryptocurrency then? It's a digital currency that is generated on and traded on the blockchain, where the value of one coin is determined by how much value people believe that one coin has. A real-world analog is necessary here. Imagine a yearly food truck festival. Each year, the festival sets up for a few weeks, and it's super popular. To buy food at the food truck festival, you buy food truck coin. The first year, you get 10 food truck coin for $10. The festival takes a cut of the sale of food truck coin, vendors charge for food using food truck coin, and at the end of the festival, they cash in food truck coin with the organizers to get real money in return. Now, people who go to the food truck festival often buy more food truck coin than they use, so when the festival is over, they end up with some food truck coin in their wallet. This is a net gain for the festival since they sold more of the coin than were actually used. Next year, the price of food truck coin has gone up, so you get 10 food truck coin for $12 instead. This means if you have food truck coin left over from last year, they are now worth more than before. So people who go to the food truck festival each year start buying food truck coin from people who didn't use it the previous year. This way, the food truck coin, which only has practical value in the festival, suddenly gains value outside the festival as well. Scale this example up, put it on the blockchain, and you get a cryptocurrency. It really is just a new custom currency people in the community believe has value, so therefore it has value, which one could argue is no different from regular currencies, often called fiat currencies. The main difference is cryptocurrencies are not controlled by a central bank and therefore don't belong to a specific country or region. That means no government can just print more money or otherwise manipulate the value of the currency. Instead, they are global and anyone can use them for whatever someone else is willing to trade them for. Which brings us back to the role of cryptocurrencies on their blockchain. Most transactions on any blockchain constitute moving crypto coin between owners on the blockchain. Only a small percentage of transactions actually do something in the real world. In other words, cryptocurrencies are mainly financial instruments for speculation. Buy crypto coin, hope that it increases in value, then sell the coin for a higher value or wait to see if the value goes up even more. Crypto enthusiasts argue cryptocurrencies are more stable than fiat currency, and that because a central bank can't just print more crypto, there's more security in crypto investment than in traditional investments in, for example, the stock market. Whether that's true depends entirely on someone being willing to buy a crypto coin for you for more than you paid. Cryptocurrencies operate through the exchange of crypto coins on the blockchain. These coins are a special type of tokens that function as the native currency of that blockchain. The coin you use depends on the blockchain you're trading on. So Bitcoin is traded on the Bitcoin blockchain, Ether on the Ethereum blockchain, Sol on the Solana blockchain, etc. This, by the way, is why we have crypto exchanges. They operate as intermediaries anytime someone wants to trade a coin from one blockchain to another. And yes, that sounds exactly as centralized as it is, which runs against the very premise of a decentralized Web3, so let's just shelve all of that for now. Anyway, a token or a crypto token is a representation of an asset on the blockchain. That asset can be a coin or it can be something else. On the Bitcoin blockchain, all tokens are coins because the Bitcoin blockchain is a cryptocurrency blockchain only. On the Ethereum blockchain, tokens can be Ether coins, or they can be assets representing other things like alternative token currencies using the Ethereum framework, tokens containing smart contracts for things like distributed autonomous organizations or DAOs, NFTs, non-fungible tokens, or a myriad of other things. So what are all these things? Let's break them down. Coins function as plain old money, just in a virtual format. They are used to perform transactions on the blockchain the same way money is used to perform transactions in the real world. They are fungible, meaning all coins of the same value are interchangeable. It doesn't matter which coin you're holding, just that you hold a coin. Coins are typically traded in fractions, so when you say you hold Bitcoin, you most likely hold a small fraction of a Bitcoin, similar to how we have dollars and cents or kronor and öre. Tokens can represent any asset. Let's look at our food truck festival example from earlier. If the food truck festival wanted to move their food truck coin to the blockchain, they could mint a new type of coin on the Ethereum blockchain called food truck coin and embed within it a smart contract that passes a percentage of the traded value of the coin to the festival organizers anytime it's bought or sold for Ether. This automatic transactions is made possible by smart contracts, self-activating logical programs embedded in the token itself on the blockchain. Tokens can be traded directly within the blockchain, but for non-coin tokens, trading typically takes place through some form of exchange of coins, i.e., you pay for a token using coins. Because of this, the coin value of a token can vary greatly depending on what asset or function the token represents. When we talk about Web3 as a decentralized web, we're also talking about Web3 as the tokenized web, where everything becomes a token and every action on the network is a transaction of tokens. For example, some decentralized Web3 storage solutions use tokens to trade storage value. So if you offer up storage to others, you receive storage tokens. And if you need more storage, you pay for that storage using tokens. So all coins are tokens. Not all tokens are coins, but all tokens are backed and paid for by coins. And it's this dominance of tokenization that makes the Web3 universe attractive to those who like to turn their environments into marketplaces. In 2021, a new buzzword went from relative obscurity to front-page news across the globe. NFT, an acronym for non-fungible token. Suddenly, there were stories of people and auction houses selling NFTs of simple computer graphics for millions of dollars in crypto coin, and everyone from Silicon Valley venture capitalists to diverse independent artists on TikTok were talking about how NFTs would revolutionize everything. Concert tickets, medical records, land deeds, funding for historically excluded and oppressed populations, all would be solved by minting NFTs on the blockchain. At the same time, there were some people saying NFTs are a scam, a new type of multi-level marketing scheme or a Ponzi scheme, that an NFT is only worth as much as the next person is willing to pay for it. And you know what? All these things can be true at the same time. Regardless of where you stand on this debate, one thing is for certain. NFTs are a thing now, and they are important because people are investing significant money in NFTs and their development. So let's ask the central question. What is an NFT? Starting at the end, an NFT is a token, a tradable entity representing an asset on the blockchain, just like a coin or any other token. However, unlike other tokens, the NFT is unique and non-fungible, meaning it cannot be copied, substituted, or subdivided. Unlike coins or tokens that are interchangeable, holding a particular NFT is important. It's the uniqueness that makes it valuable. An analogy can help explain this. Say our food truck festival wants to give their most eager supporters special VIP treatment, like cooking classes or special drinks or access to the VIP area. To do this, they issue food truck NFTs, specifying what perks the holder of that NFT has. A supporter who buys an NFT can then use it as proof they have access to the services the NFT offers. And if the supporter no longer wants access to those services, they can trade or sell the NFT to someone else, and that person gains access to the services. This example barely scratches the surface of what people believe NFTs can eventually be used for. It's also a good example of how NFTs are being used today. But how does it work? Let's break it down. As I explained, an NFT is a unique token, meaning there's only one of them. The blockchain knows this and will always treat it as a unique entity. That token can contain whatever you want, though usually they contain either hyperlinks to assets stored elsewhere on the web, like the stereotypical cartoon avatars we've come to associate with NFTs, or simple smart contracts performing some form of automated transaction anytime the NFT is activated or traded. This is because the cost of storing data on the blockchain is extremely high. As I record this course, adding an NFT containing a 5 megabyte image to the Ethereum blockchain would cost you an eye-watering $500,000 in gas fees. That's the service charge for the work. Adding an NFT with a link to an image would cost about $70. So, the NFT is a unique token that points to an external asset, performs some form of action, or does both. It's also not the asset itself. Holding an NFT of an art piece does not mean you own the art. It means you own the NFT, the token on the blockchain. Nothing more, nothing less. So, why do proponents think that this technology will revolutionize everything? For concert tickets and tickets in general, the answer should be obvious. Ticket fraud becomes all but impossible when the ticket is a unique token on the blockchain. For artists, NFTs can be minted with smart contracts that give them a portion of sale every time the piece is traded. So as the NFT is traded for higher and higher values, the artist earns more and more money. They could also be set up to grant NFT holders special privileges that change over time, like access to special events or promotions or services, or so-called airdrops, where an NFT holder gets a token or other entity dropped into their crypto wallet. Don't worry, we'll talk about crypto wallets later on. But right now, the most common use of NFTs is to sell art, raise money for a project, or to be an investment asset. See the aforementioned NFTs selling for hundreds or thousands or even millions of dollars. As for private information like medical records and land titles, the value of NFTs remains unclear. While it is possible today to place, for example, land titles on the blockchain, doing so is risky because there's no security layer in the system, and what happens on the chain is decided by consensus. So hypothetically, someone could steal an NFT land title, and it would be very difficult for the rightful owner to get it back. Additionally, the appeal of the technology and how all information is permanent and an NFT can't be copied or changed is also its Achilles heel. Adding personal information into an NFT makes it permanent and unchangeable, which is not always what we want. It's often specifically what we don't want. In short, this very small and very powerful technology is many things to many people, and it's still not clear if the good parts outweigh the bad. Considering coins, tokens, and NFTs all live on the blockchain, how do we know how many coins any one person holds, or who owns what tokens and what NFTs? This is where the crypto of cryptocurrency comes into play. To add a transaction to the blockchain, you need a unique username and password. On the blockchain, that means a public address and a private key to access that address. Think of this address as your account number. The address is assigned to any transaction you make. So if you buy a coin, a transaction is added to the blockchain saying, this address now has X number of coins. And if you sell an NFT, a transaction is added saying, this NFT transferred from address A to address B. This is the same way we manage money in our bank accounts, except it's all happening on the blockchain and there is no intermediary bank. To use an address to make transactions on the blockchain, you need to know the private key for that address. That private key is a very complex cryptographic password that has a bunch of security features built in to make it close to impossible to guess even with a brute force attack. So, when you make a transaction on the blockchain, you pass both your public key, the address, and your private key, the password. Now, because these private keys are so complex, and because you are likely to have more than one address, to keep track of all of your addresses, your public and private keys, you use a crypto wallet. This wallet is the equivalent of your digital bank card. It holds all your account information and all your passwords, and you use it to make transactions on the blockchain. The key to remember here is, just like with a bank card, whatever coins, tokens, NFTs, and other assets you own do not live in your crypto wallet. The wallet is just a tool you use to access and modify the information on the blockchain. There are several different types of crypto wallets. The most common and user-friendly version is a web-based wallet offered by a service provider. This is effectively like having a bank account. You log into the service and see all your holdings and use the service to make trades on the blockchain. And yes, this again is not decentralized at all, and your wallet is only as secure as the service provider. Over the years, millions of dollars in crypto have been stolen from wallets on these services. These services are also centralized companies that need to adhere to local laws and regulations, and over the years, accounts on such services have been seized by law enforcement or blocked due to criminal behavior or global sanctions during war, just like a traditional bank. If you don't like that idea, you can also use browser and software-based wallets where you run the software on your device and manage your accounts and passwords yourself. This is more secure, you avoid any kind of government control or sanctions, but it also means your device becomes your security feature and you take on all the responsibility of securing your account yourself. Finally, you have cold wallets, also known as hardware wallets or offline wallets. These are physical devices used to store your account information, including public and private keys. Cold wallets are typically specialized USB devices with password features built in. Plug the USB into your computer, and you are able to make transactions on the blockchain, lose that USB, and you lose access to your account forever. When you hear stories of people losing their crypto or digging through garbage dumps looking for lost Bitcoin, what they're talking about is a cold wallet being lost. It's not the coin being lost, it's that the public and private keys necessary to do transactions using the account the coin is associated with is lost. The money in your account is effectively lost if no one can access your account and make transactions with it. One important difference between a crypto wallet and a bank account is on decentralized blockchains, you have pseudonymity of addresses. The address is public and anyone can see it, but who owns that address is private and works as your pseudonym on the blockchain. In fact, you never add any personal information when you create an address on the blockchain. The only thing that exists is the address itself, and the address serves as your pseudonym on the blockchain. The reason it's called pseudonymity and not anonymity is because all transactions are public. So if you perform enough transactions using a specific address, it's technically possible to figure out who owns that address by your pattern of transactions. This brings up one final point. Because there are many different blockchains, each requiring a unique address with public and private keys, and there is a significant risk involved in buying and trading coins and tokens and NFTs, it's common practice to have multiple wallets to spread the risk around. Advanced traders often have cold wallets with most of their assets and then transfer just the funds they need onto a burner wallet for when they want to make trades. This can be done to protect your interests or to protect your identity or both. Smart contracts have become a central feature in the vision of Web3. Whereas a crypto coin or token is a passive asset, a smart contract added to a token makes it an active agent on the blockchain. A smart contract is a self-executing function embedded in a token that performs actions on the blockchain based on other transactions and events taking place on the blockchain. Here's a basic example. Our food truck festival sells NFTs giving holders access to VIP cooking classes. But since an attendee is likely to want to attend a cooking class only once, there's a high chance the attendee will sell the NFT or trade it with someone else after using it. To ensure this doesn't become a situation where one NFT is used by a long list of people without the festival earning any profits, the NFT contains a smart contract that sends 15% of the purchase price of the NFT back to the festival anytime the NFT is traded. Another example. The Food Truck Festival wants to reward multi-year NFT holders who attend VIP cooking classes, so if the same holder uses the NFT to attend 5 cooking classes over 5 years, a smart contract in the NFT is triggered and the holder is gifted a super VIP NFT airdropped into their wallet, giving them a private cooking class. Smart contracts embed contractual agreements into the asset and allows the asset itself to execute the contract without a manual trigger or an intermediary. Set it and forget it. For transactions like revenue sharing, automatic expiry, and other if this then that type scenarios, they allow us to automate complex transactions that are hard to keep track of. And because the smart contracts are on the blockchain and are self-executing, there is no room for disputes or arbitration. Once added to the blockchain, the contract is immutable, everyone can see what it does, and it will execute the function it's programmed to execute every time. This also means a poorly programmed or malicious smart contract can create serious problems for the blockchain because it's very difficult to get rid of. A poorly written smart contract meant to do revenue sharing may, for example, transfer too much or too little of the revenue each time it's triggered. This puts the onus of the smart contract functioning as intended on the original programmer, and programmers are humans who make mistakes just like everyone else. Once added to the blockchain, a smart contract is effectively forever, and the only way to block a malicious or poorly coded smart contract from executing is to override it with a new smart contract added to that blockchain. The rise of cryptocurrencies, tokens, NFTs, and smart contracts on the blockchain have led to a new type of blockchain-based organization called a decentralized autonomous organization, or DAO for short. The basic idea is you set up a series of tokens and NFTs with smart contracts, and these smart contracts execute the functions of an organization, eliminating the need for traditional organizational tools like boards of directors and accountants for membership management and revenue sharing. Let's imagine the food truck festival I've been using as my example throughout this course wants to go full blockchain by turning itself into a DAO. To fund the festival, a new type of token is issued on the blockchain called Food Truck Votes, or FTV. The festival sells these tokens to food truck owners and to fans of the festival. Holders of 100 or more tokens get voting rights when decisions are made about the festival, like what food trucks are allowed to attend, when the event should take place, the price of food truck coin, etc. Each FTV is worth 1 vote, and smart contracts are used to track who can vote, what they vote for, and what the results of those votes are. Food trucks that win the vote to be in the festival are issued special food truck NFTs with smart contracts that expire after 1 season, and holders of FTV tokens are paid a share of the revenue from the festival based on how many tokens they hold. If this sounds a lot like a regular shareholder company, that's because it is. Just instead of shares being issued and shareholder meetings being held, special voting tokens are issued, and token holders meet in chat forums like Discord to discuss how to place their votes. For this reason, I like to think of DAOs as shareholder organizations wearing crypto jackets. It's a new way of doing an old thing: fund and operate a complex business with owners holding competing interests. The appeal of DAOs is everything is done in public. All the rules of the organization are embedded in self-executing smart contracts. Those smart contracts are public on the blockchain, so anyone can inspect them and see how they work. And the often nebulous and inscrutable rules of organizational management are transformed into immutable, automated transactions on the blockchain. Assuming the smart contracts are coded correctly and all conditions and eventualities are accounted for, the operation of the organization becomes autonomous and the DAO blockchain assets become the literal code of the organization. At present, in the wild, DAOs are used as a way of raising money for projects, managing the day-to-day operations of small organizations, and enabling things like transparent revenue sharing. Some crypto enthusiasts envision a future where DAOs will become the new standard and most organizations will be automated, eliminating the need for expensive intermediaries like lawyers. Allow me to interject my personal opinion here for one moment. I think this is a bit of a utopian dream for many reasons. Here are 3 of them. First, writing organizational smart contracts is complex, and they involve both legal and financial risk and liability. For this reason, smart contracts need to be written by the same expensive lawyers and accountants currently writing organizational contracts, and likely will need to be maintained and managed by those same expensive lawyers and accountants. Second, organizational work is human work. There are always countless unwritten rules and unforeseen events that play into the day-to-day management of an organization that just can't be captured in self-executing contracts. Even within fully functioning decentralized autonomous organizations, much of the work will remain very much centralized, manual, and human. And finally, organizational management and decision-making is difficult. There are often competing interests, limited budgets, and other constraints requiring decision-makers to have deep and broad understanding of what's going on to make sound decisions. This is why organizations have boards of managers to make decisions, and why direct democracy within organizations often leads to stagnation or apathy, where only a small portion of people with voting rights actually use their votes. Bottom line, no matter how fancy the blockchain jacket, organizations will find it a challenge to write code to replace human interaction.
As we wrap up this course, I want to address a very important question. Is Web3 going to be the next version of the web? And related to that, is the Web3 I've described in this course the future you want to see for the web and for finances? The answer to both these questions is it depends on a lot of variables, and one of those variables is you. Web3, as presented here, is an idea proposed by people with a very specific vision of what the future should be and how it should work. That idea appeals to some and seems like a very bad idea to others. Right now, Web3 and blockchain-based technologies have a lot of backing from venture capitalists and people heavily invested in cryptocurrencies and the financial markets. As for the web community, there is much less overlap. For this proposed third version of the web to win out, a lot of technical infrastructure on the web needs to be completely rewired and redesigned, which is work largely unstarted as I record this. That means if this idea appeals to you, there is a community ready to bring you on board and get you started. If, on the other hand, you don't think this should be the next iteration of the web, there's also a community out there building decentralized solutions without tokenization and cryptocurrencies and blockchain at its base. Whatever form the next evolution of the web takes, you will be part of making that happen. So use this course as a starting point to educate yourself and those around you about what this Web3 idea is and what you think the next version of the web should be. And if you want to talk, you can reach out to me on LinkedIn, Twitter, or TikTok, and we'll work it out together. Now all that's left for me to say is lycka till as you explore the possible futures of the next web, and I'll see you in the next course.